With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, in this question we are considering an element as successive ionization enthalpy as 940. So first ionization is 940, then we have 2080, so second is very high, then we have 30, so somewhat difference 4140, then we have difference of 70, so 3000 difference is there, then we have 7870, and again we have a large difference over here approximately of 7000, then we have 19,000, so difference of. So where the difference arises, we need to check, and finally we need to predict to which group of the periodic table this element is going to belong. So I am taking one example and solving the correct solution. Then I will explain how we are going to deal with the set of elements. So what do we observe? First is going to be, so basically we need to see the difference where it is arising and due to what that difference is coming. So where is the removal of electron taking place? So first is going to be 940 value. And as we compare the first and second, so there is going to be sudden change. That means the electron is going to be removed from the half filled or stable configuration or full filled stable configuration. So that predicts it's going to have this value as the weak, and this is going to be sudden change. So here change come, and over here there is little change of 1000, so that's normal. Here also 1000 change, but here you see 3000 change. That means there also some stable configuration, half filled or fully filled, is going to be disturbed, and over here you see just a single difference, and over here there is going to be approximately 7000 difference. So here also configuration is going to be disturbed, maybe inertial electrons are disturbed, and over here there is a difference of 3000. So let's proceed. For example, if I take off our oxygen atom to explain this, its configuration is 1s2, 2s2, 2p4. If I represent 2p4 over here, so 1, 2, 3 and 4, and this is 2s, so this is the valential where ionization takes place. Now let me consider, to remove first electron you need to do some effort, that is 940, so its first ionization is going to be 940. I am taking a demo example, this is not correct solution, so I am explaining how to deal with that. 940 is somewhat less value because this is going to be 3 are already stable and 4th is added basically, so this is going to remove out. Now when you trying, this is first. Now when you are removing the second electron, so after removing of first, this is going to be half filled stable configuration, so its value is going to be very high. Why? Because its half filled configuration is going to be form stable configuration, stable orbital configuration. That's why this value turns out to be 2080. So 2080 is due to stable half filled configuration. So I am writing stable half filled configuration is the reason. Now if you proceed with the third, so if you remove this electron, or electron will be removed from this side valence, now you are left with 2, so this can be removed easily. That's why IE2 is given as less value, that is difference is going to be only of 1000. Difference is arising, why? Because as we are removing electrons, size is going to shrink because of increase in effective nuclear charge, because number of electrons are decreasing and proton is going to be number same, so that's why overall size is going to be more smaller as the electrons are being removed out. So that's the reason the values are always increasing order. Now if we compare IE2, then we compare IE3. So IE2 we have removed out, then we have removed till third ionization we have done, so third is done. Now fourth you are removing, 4 is also going to remove because they are singly now, so fourth is also going to be somewhat easy, so 3, then we have value of 4140. So I have to tell the reason of increasing because of decrease in size. Now when we are going with fifth ionization, so what happened, this fulfilled configuration of S is being disturbed, that's why this energy turns out to be very large difference of 3000. So this is going to be our disturbing of inner S orbital of 2s, so this value turns out to be 7030, which is high. So over here we have change, and this was the change. Now let's proceed with the next set of value. There is going to be small change of 800, because of this one electron will be removed out, so one will be there, so it can be removed easily. So IE6 is going to be somewhat less value, less difference value, so this is 7870. Now if you consider these are now removed, now we are having 1s only, which is the most stable, or the inner, which is exactly near to the nucleus. This shell is exactly nuclear inside to the nucleus, so there arises a very large difference of 7000 approximately. So this is going to be the turning point where we can directly say this is the inner shell. So this is going to have 1600 value. Now if you remove this value, this is going to be somewhat or small size, so this is turns out to be more small size. After removing first, we have the smallest size possible because of one electron and number of protons are many more. So this turns out to be very large value of 1950. So IE8 turns out to be 9500. So now you need to predict the element. So total values 1, 2, 3, 4, 5, 6, 7, 8 are given correspondingly. That means 4 plus 2, 6 and 2, 8. Total of 8 they have ionized. So this is going to be oxygen element, which belongs to our option 16th group, oxygen, sulfur, cerium. So 16th is the answer. Or you can also predict on the basis of stable configuration what we have done. If you also do for another set of elements like fluorine or any other, so it's not going to show that 1s2, 2s2 or 2p, 5 will be there. So 1, 2, 3, 4th, 5th. So first is going to be smaller, second is smaller, then third ionization is going to be more difference in there. So what we have observed on the second value, this large change, in case of fluorine we are going to observe that same change in the third ionization. So this is how you are going to predict the element. So our answer is C. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.